Now we're going to look at determining the end behavior for polynomial functions. So if you have a positive leading coefficient and you have, scroll this down a little bit, positive leading coefficient, so a sub n is positive, and it's an even power. I'm not sure why it doesn't say that, but it's an even power. As x gets bigger, it's going to go to infinity. As x gets really small, it's also going to go to positive infinity. But if you have an odd power and a positive leading coefficient, as x gets bigger, it's going to go up, it's going to get bigger. As x gets smaller, it's going to go down. And if you have, again, n is even, as x gets bigger, it's going to go to negative infinity. As x gets smaller, it's going to go to negative infinity because it basically is reflected across the x-axis. Likewise, n is odd, and you have a negative leading coefficient. So as x gets bigger, it's going to go down. As x gets smaller, it's going to go up. And let's talk about some turning points. A turning point is a point of the graph where the graph changes from increasing to decreasing, rising to falling, or decreasing to increasing, falling to rising. A polynomial of degree n will have at most n minus 1 turning points. So find the maximum number of turning points for each of the polynomials. So this one is a cubic, so it'll have at most n minus 1, which is going to be 3 minus 1, so it'll be 2 turning points maximum. For the next one, so notice it's going to be, this will give us a squared term, and this will give us it has a square term. So that'll give us like a 2x to the 4th power. Now it's negative here, so we could say it's negative, but that's not the point. The point is turning points. So we look at n minus 1. In this case, it's 4 minus 1, which is 3. So 3 turning points maximum. Okay, that's it for this video. The next one we're going to talk about, you see right here, graphing polynomial functions.